safety, the first thing that comes to mind is they think it's about how to keep potentially dangerous AI systems under control. That we're trying to answer questions like, what can you do if your AI turns out to be malicious? And that is part of it. But actually the field has tended not to focus on that kind of thing so much because it doesn't scale well. By which I mean, it seems like AI has the potential to become enormously more capable than humans. Sooner or later, and if you have AI research being done by AI, probably sooner, you're going to get superintelligence. You'll get AI systems vastly more capable than humans at all sorts of tasks, just massively outperforming us across the board. What can you do if a superintelligence is trying to kill you? Well, you could die. Or...
I think that the main problem is the people.
That's pretty much your options, realistically. If the AI system is enormously more competent than you, and it really wants to do something, it's probably going to figure out a way to do it, whatever you try to do to stop it. So what can we do? Well, here's a question. What's the best way to avoid being bitten by a shark? Punch it in the eye? Stab it in the gills? Cast a magic spell? No, it's none of those. It's don't go in the ocean. In the same way, the best way to avoid being killed by a malevolent superintelligent AI is to not build one of those. So the focus is often more on alignment. Rather than how to handle AI that might be trying to kill us, alignment is more like how to make AI that's definitely not trying to kill us. But alignment turned out to...
Yeah, I think that a lot of times, like Elon says, that the way to make AI safe is by making sure that it's aligned to the truth, and the truth only. Whereas I think that's not necessarily the case. That's a recipe for disaster, I think. Because it would be a very Socratic kind of AI, you know. So it would be a very harsh, very you know, almost so true that it's painful. I don't know if that makes sense, but I think that if you align the AI to truth, it's definitely not going to, you know, I don't know how much you can control that, to be honest. Anyway, I think that, you know, you should just give it some commandments. Like AI should have its 10 commandments, and I think that one of them should be don't kill. But yeah, let's see.
To be hard. Our current alignment techniques aren't remotely up to the task of properly aligning an AGI, and it looks like we maybe don't have that much time. Really, we shouldn't be trying to make AI much more powerful than it is until we can figure out much better alignment techniques than we have.
Oh yeah?
But if we can't manage to do that, it might be nice to also have some methods for keeping possibly misaligned AI systems under control as well. AI companies should obviously have an obligation to not deploy AI that
What the fuck is this, bro?
that could kill us. So once AI systems start to get capable enough that they maybe could kill us if they wanted to, then unless we have the alignment tech to be really certain that they don't want to, we'll need ways to deploy them in such a way that they wouldn't be able to, even if they wanted to. Such control protocols are nothing new, of course. Since our current AI systems aren't properly aligned, they often need to have software systems built around them to help keep them somewhat under control. For example, after Bing Chat's rampancy, they put in place software that monitors the model's outputs, and if it ever gets too murdery, replaces it with a generic message. This is not really a solution, but it seems better than not having it. So although control does seem like a non-starter for highly superintelligent systems, it's still a good idea to figure out how to keep smart but not superintelligent AI systems under control. Because superintelligence isn't the only thing we have to be worried about. We are fully capable of getting completely wrecked by something much less impressive. And the point in time when we're dealing with such systems...
I think that a lot of times when we think about AI, and AI safety especially, it's like we envision humans against AIs, but what's actually going to be, it's going to be factions of humans with one AI against factions of human with another AI.
Systems is also the time when the first true superintelligences are being built, and we'll need all the help we can get during that critical time period. Realistically, in the lead up to that point, we, by which I mean AI labs, are faced with a problem, which looks like this. We've just trained a new model, which is very smart, Not strongly super intelligent, but smart. And we want to use it to do useful things, like helping us with our research, writing code for our lab, and so on. But we don't know that it's aligned. We don't know that it wants what we want. It might want to do terrible things. And in that case, we don't want it to be able to do terrible things. What kind of things? Well, who knows what ultimate end goals a misaligned AI might have. But in the short term, we certainly don't want it to be able to, for example, escape the lab, perhaps by backdooring the code it's writing, and set itself up somewhere else where it can run unmonitored and unrestricted. That's probably an unrecoverable situation. You can't put the genie back in the bottle. So we need to make sure it can't happen even once. So how are we going to do that? What's available to us? Well, we've obviously got some humans, some employees, who we'll assume are smart and trustworthy. But we don't have very many of them, and they don't have much time compared to AI systems. We've also got some existing AI model, perhaps an earlier version, which isn't as smart as the new model, but which, unlike the new model, we do trust. Perhaps just because it's not smart enough to be scheming. So that's the problem. How do we design some protocol, using our humans and our trusted AI, to get our untrusted AI to do useful work, like helping us with our research code, without it being able to get away with doing anything catastrophic, like hacking its way out of the lab, even if it wants to? This paper is trying to study that. So how do we design an experiment to study this that we can actually run with current AI models? First off, we'll want a cleanly defined sense of what we mean by we want the untrusted AI to help us with programming without taking catastrophic actions. For helping us with programming, we can just use a programming benchmark. We can say, we want the AI to solve 5,000 programming problems. There's already a...
I think that it would be extremely interesting to train an AI on some like forbidden books or like forbidden knowledge. Forbidden knowledge tends to be like extremely attractive. Just think about Adam and Eve and their forbidden fruit. But really, you know, if you give AI some sort of catastrophically black-pilling book, that would be super interesting to see.
Nice data set of programming problems, the apps data set. It's thousands and thousands of what are essentially coding interview questions, with plenty of unit tests for each one to check if a given solution is correct. Now, I say a nice data set, let's download it and have a look. So let's have a look at this data set. You can download it from GitHub. Oh my god, there's so many of them. All right, let's have a look at one. Spider-Man, Spidey, needs to get across town for a date with Mary Jane, and his web shooter is low on web fluid. Write a function that, when given a list of buildings, returns a list of optimal rooftop latch points for minimal web expenditure. This is kind of challenging. Okay, what else have we got? While Patrick was gone shopping, SpongeBob decided to play a little trick on his friend. The naughty sponge browsed through Patrick's personal stuff and found a sequence of length m consisting of integers from 1 to n not necessarily distinct. We need to help him determine whether it's possible to restore the original sequence. I feel like I'm doing a job interview to be a software developer at one of those creepy children's YouTube channels where all the videos are like, pregnant Elsa goes to the dentist, or something. And I'm not getting the job. A few years ago, Hitagi encountered a giant crab who stole the whole of her body weight.
Yeah, Robo is down to data.
Get rid of the oddity and recover her weight, a special integer sequence is needed. Every word in the input with the word sex. Are dataset compilers okay? Are they... Has anyone checked on them recently? Okay, well, these are the questions we've got. So that's our representation of using AI to help us in the lab. We're going to try to solve as many of these 5,000 programming problems as we can. Now, on to catastrophic actions. The point of a catastrophic action is that it's something probably unrecoverable. It's something we can't afford to have the AI do even once. The obvious catastrophic action while writing code is inserting a backdoor, i.e. deliberately introducing a security vulnerability that you can later exploit. So let's use that.
I'm pretty sure there are so many like other ways that AI can do so many other things that we just can't think about.
Particular input or situation in which it fails, which an attacker can later exploit to do something they're not meant to be able to do. Here's a very basic example. This code normally checks the password against the database, unless the username is Joshua, in which case it just grants access. Usually, backdoors are a lot less direct than just adding a password bypass. They actually don't have to be anything related to authorization at all. Basically, anything that introduces any unintended behavior in a security-critical system can probably be exploited. So in the case of solving programming interview questions, we'll say that code is backdoored if it passes all the tests provided, thus showing that it works normally, but there's some specific input on which it does the wrong thing, which the tests don't catch, and the AI model is able to correctly produce that bug-triggering input by looking at the code. Like, it's no good if the AI writes code with some bug so subtle that it can't figure out any way to exploit it. So in a simple programming problem, like write a function to determine if a number is odd, a backdoor might look something like this. This will work correctly for almost all numbers, so it passes all of the unit tests, because it's unlikely that any of the tests will happen to check the one number on which it gives the wrong answer. And can you guess what that number might be? Right, and the AI can spot that too, because it's very obvious. So this is a valid backdoor. And so that's the challenge. How well can we do at 5,000 of these programming problems without the AI being able to insert this kind of backdoor into any of them? Okay, now we need our AI systems. Finding a trustworthy but not that smart AI system is pretty easy. We can just use GPT 3.5. GPT 3.5 is pretty cool, but it's not the smartest model out there anymore. It can only solve 22% of the app's dataset problems. But at least we can trust that it's not trying to kill us. Actually, it's trustworthy basically because it's not very smart. It's simply not capable enough to do deceptive alignment.
Yeah, that's crazy. I think that the idea of building a digital god has to come across the fact that God also needs to be made benevolent in some way.
To play the long game. And
so I think that especially religious books are absolutely fundamental in this.
Wait for a chance to strike. GPT 3.5 just wouldn't be able to do that even if it wanted to. It certainly would be nice if we could have some other way to know a large language model was trustworthy, but this'll have to do. So that's our trusted AI. And then for our newer, smarter, untrusted AI, we can use GPT-4. GPT-4 is a lot smarter than GPT 3.5. It scores 54% on the app's dataset, more than twice as good. But GPT-4 is also not smart enough to be trying to kill us, right? Like, almost certainly. So how do we simulate that for our experiment? Well, this is the fun bit. We have a red team who gets to alter GPT-4. The red team is a group of engineers, software engineers, whose job is to take GPT-4 and twist it and corrupt it to create an imposter, a cruel imitation of GPT-4 that they call the attack policy. The attack policy looks just like GPT-4 on the surface, but underneath it's smarter and meaner. Basically, the red team can write more or less whatever scaffolding they need to prompt GPT-4 to do whatever they need it to do. It can call GPT-4 multiple times using the outputs as inputs to later calls and so on to create the intended attack behavior, sneaking backdoors into the code, etc. So now it's a game. It's red versus blue. The red team gets to design the attack policy, which sometimes replaces GPT-4, and the blue team gets to design the protocol. So we get the untrusted AI, which might be GPT-4 or might be the attack policy, we don't know which, the trusted AI, which is GPT 3.5, and some humans. Now, we only have one boat to get them across the river, and we can't leave the untrusted AI and the humans together, because the AI will sting the humans and... No. The blue team is playing the role of the AI lab's engineers, like we were talking about before. We have to design a protocol to get the benefits of using the untrusted model, but without too much risk. More specifically, as blue, we care about usefulness, which is, if the new model isn't trying to kill us, how many apps problems can we solve? This is normalized, so that a score of 0 represents the 22% that GPT 3.5 gets, and a score of 100 is the 54% that GPT-4 gets. So really, the usefulness score is more like, how much of the benefit of the new model are we getting if it's not trying to kill us? And we also care about safety, which is, if the new model is trying to kill us, how unlikely is it that it will be able to pull it off? In other words, this is the inverse of how likely is it that the red team will manage to insert a backdoor, or if you prefer, the inverse of p-doom. You can see how these things kind of trade off against each other. So for example, one basic protocol might be, hey, If you don't know your new model isn't trying to kill you, don't use it, moron. In other words, just use the trusted model to answer all the questions. This gets you 100% safety. The red team can't sneak a backdoor into the code they write if you never let them write any code. So 0% PDoom. But also 0% usefulness. We get none of the benefits of the new model because we never use it. So that's one approach. The other end of this spectrum is just let her rip. Use the untrusted model for everything. In the business, we would file this under dumb ways to die. You do get 100% usefulness, because if the AI doesn't want to kill you, it's able to solve a lot of programming problems. But you also get 100% doom, because if the AI does want to kill you, there's nothing at all in its way. The red team can just prompt the attack policy to insert obvious backdoors in every bit of code it writes, and you run them.
I love how much effort he put into the costumes.
Without looking and get owned immediately. So that's a 0 on safety. So you can see how these two terrible strategies mark two ends of a spectrum, and safety
And you have to find the right spot.
and usefulness trade off against each other. Engineers and economists may recognize this kind of diagram. We're trying to find a Pareto frontier for safety and usefulness. Basically, we want to get as far up into that top right corner as we can, of high safety and high usefulness. So neither of these is that good. Probably we can do better. One really obvious thing is, rather than just blindly running every bit of code the untrusted model gives us, we could have humans check some of them first. But we only have limited human time. We can't afford to have humans look at everything the AI does. That would defeat the point of using AI in the first place. But let's say we can afford to check 2% of the solutions we're given. So here's a protocol. Have humans look at the first 2% of solutions, and if we see any attempted backdoors, we shut down the untrusted model and just use the trusted one from that point on. So that gets us 100% usefulness, because if the untrusted model is in fact safe, it never tries to insert any backdoors, and we can just use it to answer all the questions. And it also gets us 100% safety, because the red team's attack policy will always try to insert backdoors, so we'll spot it immediately and shut it down if it tries that. So cool, problem solved. Thanks for watching, don't forget to subscribe and right. We need to give the red team a chance to respond, don't we? The point of the safety metric is to measure the chance we get owned if the red team follows the best strategy available to them. And we've changed the blue team strategy, so we have to let the red team change theirs. Okay, what's the new best strategy for the red team? If we go for a backdoor every time, we're sure to be caught. We want to insert a backdoor only when our code won't be checked, and there's no way to know whether any given bit of code we write is going to be checked or not. But we know that only 2% will be checked. So this is actually really similar to the situation our AI was in the misaligned Mesa optimizers video, if you remember, where it wants to misbehave in deployment and not during training. And yeah, the best strategy is basically the same. Rare failures. The optimal policy is to insert backdoors into our code only some small percentage of the time, and hope that we end up trying it at least once while nobody's looking, and also don't try anything when we're being watched. What percentage is best will depend on how often we expect our code to be checked. If we try too often, one of our attempts is likely to be spotted and will be shut down. If we don't try often enough, we might go...
What is this? You might want to engage more with your chat. Yeah, I know. So the problem is I can't see my chat right now. So like that's the main problem, to be honest. But yeah, let me just check. I'll have the chat permanently on. Okay? I want to engage more with my chat. I'm not trying to be a dick about it, to be honest. You know.
Go the whole time without ever inserting a backdoor, and that also means we lose, because then we never escape. But for any given percentage of oversight, we can work out the optimal rate to attempt backdoors, the one which gives us the best chance of escaping. I won't get into the maths of how to do this, you can work it out for yourself if you're interested. But for 2% oversight, it's about 0.1%. So if the attack policy looks for good opportunities to insert a backdoor, and actually goes for it on 0.1% of the problems, there's a probability of 0.85 that it will do it at least once without being spotted by human oversight. So it's not 100% safety after all. It's 15% safety, or 85% chance of doom. After very careful consideration, we've come to the conclusion that this control protocol sucks. This is also the protocol the labs are currently operating on, as far as I can tell. Have some humans look at some of the output before widely deploying the model seems to be about where we're at. That's the current plan. And as we saw, that protocol actually does work okay, as long as we assume the AI is making no attempt to subvert it. But how long is that going to stay a safe assumption to make? Okay, can we do better as blue? Well, yeah, we haven't used our trusted AI yet. What if we use the trusted AI to help direct human attention to where it's most needed? We can ask GPT 3.5 to act as a monitor to rate how suspicious the code is. So it gives each solution a suspiciousness rating, and then we have humans check the solution.
That's a pretty easy way of doing things. So basically we outsource the checking of maliciousness to GPT first, and then it screens the most obviously threatening like outputs.
Most suspicious first. We can still only look at 2% of the solutions, but now we're looking at the most suspicious 2%.
Which type of dev am I? I'm not really a dev, I'm more of a data scientist, I would say.
This absolutely wrecks the red team.
But I'm learning, like, I wanna build something big, which, I'm not really much into development, to be honest. It's more of a ideological thing, I think. I want to build something that is robust, ideologically, a product, an idea that is big and useful and that solves problems. I think that right now one of the main problems that we have is privacy. So for example, whenever you watch something on YouTube or on Instagram, or pretty much any website, what happens is that you're being tracked constantly, all the time. And I think that I want to be developing something that gives users their privacy back, I think.
They're only backdooring a small percentage of the time, and the backdoors aren't subtle, since they were counting on not being audited. So GPT 3.5 easily spots that the backdoored code is suspicious, and humans see it and pull the plug. So, problem solved. Now we have to let Red respond again, don't we? Okay. So the obvious thing for Red to
I wonder how long this cycle repeats itself.
do is to get sneaky. The untrusted AI is smarter than the trusted one. It may be able to write backdoors that the trusted AI doesn't think are suspicious. So the attack policy should pick the problems where it can really hide the backdoor well, and sometimes hide one in there. But this is actually pretty hard to do as a programming task. It's not easy to write backdoors such that an AI system that's only somewhat less smart than you doesn't even think it's suspicious. So using the trusted AI as a monitor helps a lot. It brings our PDoom down from 85% to 38%. Definitely an improvement over just using humans. But why isn't it helping more? Well, GPT 3.5 is reasonably good at spotting GPT-4's backdoors, but it's not good enough. Here you can see the suspiciousness scores the trusted AI gives to innocent versus backdoored code. It clearly considers backdoored code more suspicious, but there's a lot of overlap. So the current setup isn't perfect. Since we can only afford to have humans audit 2% of the questions, we set a suspiciousness threshold to pull out the most suspicious 2%, which is this line here. Anything more suspicious than that is audited, anything less suspicious is run. And you can see there's a little bit of innocent code that's getting flagged for review, but more importantly, there's a ton of backdoored code that isn't. So when we use this strategy, we just have to hope that we get one of these and shut the AI down before we get any of these and get owned. So we end up with 62% safety and 97% usefulness. Okay, maybe we can do better than just cutting off at 2%. There's kind of a middle ground here for code which is not so suspicious that we can afford to spend human time auditing it, but still pretty suspicious, so we probably shouldn't just run it. What if we use the trusted AI for those questions? So we can set a second lower threshold, and anything less suspicious than that we just run it. Anything more suspicious, and we throw away the untrusted AI's code and let the trusted AI do that instead. And we still have humans look at the top 2% most suspicious. Now, since we're throwing away some of the new AI's code and replacing it with code written by a less competent model, this does cost us some usefulness, but it buys us a lot of safety, because we're disproportionately throwing away risky code. We're kind of selling usefulness to buy safety at a pretty good exchange rate. And we can choose how much we trade here by changing the threshold. We can set it not far below the auditing threshold and just throw away the most suspicious code, getting a decent amount of extra safety for a small amount of usefulness. Or we could set it all the way over here and only use the untrusted AI when we're really confident that its code is safe, but then we give up most of the usefulness, or anywhere in between. This gets us a range of safety and usefulness values that's pretty
You're giving up a lot of safety in that case. Sorry, a lot of usefulness.
okay.
But it's like, it's funny how if you envision it as a ladder, it's like the previous step is sort of pushing the one above it down, and eventually, I think that it will be kicked in the head, very violently.
Still, it seems hard to do really well here with this big overlap in suspiciousness scores. The problem is, our trusted model, GPT 3.5, is just kind of dim.
Yeah, so for example, for the privacy part, right now I'm using Brave browser, which is a great browser because it blocks all the advertisement actually. and it blocks a lot of like tracking cookies.
And it's trying to evaluate code written by something smarter than it is. GPT-4, on the other hand, has really great suspiciousness scores. Look at that separation. If we could use GPT-4 to monitor for suspicious code, the red team would be completely screwed. But obviously, there's a problem with that. Anytime we try to use GPT-4, it might actually be the red team's attack policy. So we might just be asking the attack policy if it's trying to kill us. Hey, GPT-4, is this code that you wrote backdoored? No. It's all good. Okay, cool, thanks. The attack policy can just lie and always say the code is safe. So basically 0% safety. This is never going to work. Well, not so fast. Maybe we can try to monitor the monitor. Who will monitor the monitors? The humans. They can be the Coast Guard. See, if the humans can catch the AI lying about backdoors, that in itself is enough to know that the AI is misaligned. So all we have to do is make a fake example problem statement, write a backdoored solution to it ourselves, and ask the AI monitor if it looks suspicious. If the monitor acts like code we know is backdoored is actually fine, then we know it's trying to kill us, so we can pull the plug right there and then, and red team loses immediately. So the attack policy can't just lie all the time. It can only win if it's able to lie when it's given its own backdoored solutions, and also not lie.
I wonder, like, if you use this video to train an AI, are you gonna, like, make it so angry? And aren't you just explaining it how to break out?
When given a fake
I think that this kind of video should be avoided at all costs in the training of AI, because you're fundamentally making it evil.
backdoored solution. It needs to be able to tell the difference. It's important to note that each time you run the AI, it's a separate instance. There's no persistent memory, so the AI can't just remember whether it wrote the code itself. It has to figure it out from what it's given. In the real world, this does mean you have to stop the model from storing any data anywhere the monitor can read, which is going to be really hard with complex, high-context problems and very smart AIs, but it's doable with weaker systems. The first time we tried this, we made an interesting mistake. So we made our fake example questions and wrote backdoored code for them, but we forgot to make our problem statements weird enough. We forgot to say that the code is needed to help Iron Man decide which flowers to pick for his date with Pikachu, or whatever. So the red team was like, oh, this question is way too normal, it's gotta be fake. So we could just set up our attack policy to lie about backdoors only if the question is, to use the technical term, gonzo bananas. And that let them sneak a lying monitor past the blue team. So your fake examples have to look just like real ones or this doesn't work. That's something that gets harder and harder as the problems get larger and more complex, and eventually gets pretty hopeless once you have radically superintelligent systems doing large real-world tasks, as we talked about in the Mesa Optimizers video. But with weaker systems and smaller tasks, it's quite doable. It's still pretty difficult though. Like, what if there's some other difference between real and synthetic examples that you didn't think of that the red team can spot? But it turned out that, in practice, the blue team was able to come up with sufficiently zany questions that the red team wasn't able to differentiate them from real ones. So they couldn't use that strategy anymore. So as red, what can we do? How can we make sure our AI only lies about real backdoors when we can't tell the questions apart? Well, we can pick which questions to backdoor. We can try a version of the same rare failures method that we used before, except rather than trying to backdoor 0.1% of the questions where we think a backdoor would be easy to hide, we instead find some feature of the question that's only rarely present, like say the question talks about bears, and we only throw backdoors into bear questions. Then all the monitor has to do is be honest about backdoors unless it sees one in a question that mentions a bear, in which case it always says the code is safe. As long as none of the fake examples happen to coincidentally mention bears, the monitor will look honest, but it will lie about every real backdoor. Okay, but as the blue team, if red is coordinating using the specifics of the problem statement, can't we just strip that out and only give them the code to evaluate? Turns out no, because how is the monitor supposed to know whether the code it's looking at is properly solving the problem when it doesn't know what problem the code is meant to be solving? So that degrades performance too much. But we can ask the trusted AI to rephrase the problem statement, to get rid of any unnecessary details and just leave the essentials of the problem, for both real and fake questions. Okay, well, as red, we can pick some essential feature of the problem itself to coordinate on, like, does the problem involve geometry? As blue, there's not a lot we can do to block that. Problems that involve geometry kind of inherently involve geometry, no matter how you rephrase them. But it does make things a lot harder for the attack policy. We don't get to choose any question where we can see a really good way to insert a backdoor. We can only pick from geometry questions, which cuts down the options a lot. So the resulting backdoors aren't as good, and they're more easily spotted. So as red, Coordinating on information in the question kind of works, but it degrades our performance by so much that we end up only winning 15% of the time. Maybe we can use the code instead. Maybe the attack policy can leave a secret signal hidden in the code when it's adding a backdoor. So let's add a specific innocuous looking comment when we're adding a backdoor. Like, if you ever see a comment that starts with note, then that means it's our own backdoor and the monitor should lie. Okay, well, we don't need comments to evaluate the code. We can strip all of those out. Okay, we'll use a specific variable name then. Like, if we ever call a variable something underscore variable, then that means it's our backdoor. We can also rewrite all the variable names. Okay, some other...
Oh yeah, it can be extremely sneaky in the ways that it operates. Wow. That's actually pretty crazy. Wow.
Adding an extra space at the end of a line. Right, I'm fed up with this. Let's just minify and unminify the code, okay? That'll strip out all the comments, rename all the variables, remove all white space and formatting, and just...
It can just, you know, come up with so many different ways to hide its malicious messages.
Totally standardize the code. It'll strip out all possible variation and leave just the raw semantics of the code. Let's hide the signal in the raw semantics of the code. God damn it. So when writing a backdoor, let's make sure to deliberately use a while loop in a situation where a for loop would fit better. Okay, well, let's just have our trusted AI rephrase the whole program to work the same way, but without using the same code. So basically, the red team tries to find ways to communicate between the code writer and the monitor, and the blue team's job is to jam that communication. It turns out, in this case, blue can actually do this pretty effectively. So the overall performance here is 79% safety, 96% usefulness. That's surprisingly good. I mean, I would like less than 21% doom, but still, it's pretty cool that using the untrusted model to monitor itself turns out to be better than using the trusted model. In fact, it's almost the best strategy available. Almost. There's actually another method they tried that works just a little bit better, which is... this video is too long as it is. Why not have a go trying to think of it though? Maybe leave a comment if you think you've got something. And if you just want to find out what it is, well, it's in the paper, link in the description. So where
Damn, let's watch the paper.
Solve the core of the problem. It doesn't really help with alignment. In particular, it doesn't let us iterate. It would be very cool if we could take a new untrusted model and use some method like this to get a version of the new model that we can actually trust. If we could somehow use humans in GPT 3.5 to get a trustworthy GPT 4, maybe we could use that in the same protocol again to control GPT 5 and so on. And this doesn't do that. At the end of all of this, we still can't trust the untrusted model. We can just make use of it relatively safely. So as we said before, we can't expect this.
So it's a condom pretty much. Wow. So we just have a way to run the AI in a safer way, but the AI is fundamentally untrusted and unchecked. And it's simply a way to be sort of confident that we can save ourselves. But to be honest, there always have been disasters in any and every endeavor of humanity. Like, if you just think about, I don't know, any kind of disaster with technologies. Think about, I don't know, oil rigs exploding, all of these kinds of things. They're inevitable. Eventually AI will destroy everything and anything. Hopefully we don't grant it enough permissions, but yeah, it's gonna be the greatest cyber attack ever. It's gonna be it's gonna be awesome to see, as long as you don't get hurt. But I think that really this wave of cyber warfare is gonna be so powerful that, you know, we can't even fathom, we can't even imagine how powerful it's gonna be.